Good afternoon, everybody. Just a quick disclaimer, like was just said. I was until very recently the chief data scientist at Domino Data Lab. It's important to know that this is all, what I'm presenting to you is my opinions from my experiences through my career until about 6 weeks ago. Absolutely, positively nothing I say in this talk has anything to do with my current employer. And that's important that I say that up front. So thank you very much. So what are the goals of this talk? Why am I giving this talk? Well, first I want to share with you some of the patterns that we've seen as Domino Data Lab in the most advanced data science organizations that we work with. We're very fortunate to work with world-class data science organizations from financial to the healthcare sector to biotech to really pretty much everything in between. And we've recognized that there definitely exists a thread of patterns among all of them when it comes to how do they scale their quantitative research teams and their quantitative research practices. From that, you may be able to figure out a strategy for implementing these ideas in your own quantitative research teams and practices. I don't believe that there exists a single template that you can just sort of stamp out across every organization, but there have been some key learnings that we have that I think you can take into almost every organization that is trying to get, from 0 to 1 data scientist is tough but doable. You have to hire a very smart person, give them a MacBook Pro and access to the database. From 1 to 2 data scientists, you have to just make sure that they sit next to each other. After that, there are real significant challenges into scaling an organization. And so hopefully there's some strategies in here that you can learn a little something about. And very literally, we built the Domino Data Lab platform explicitly around a lot of these best practices we've learned. And I'm very literally going to show you the literal Domino product and walk through a few bits of it, and hopefully you can see some of the things that we built, and you can either say, oh, I see how that would be useful, or you can understand how you would implement something similar inside of your organization. So just real quick, right, there's going to be a short introduction, there's going to be some motivation, and that's really the meat of the talk. Then we'll go into the bits and pieces. What are the architectural chunks that you need, the silos that you need, the cross-functional elements that you need, and that'll include the product demo. So as a quick introduction, who am I? Why am I here? Why should you spend your precious time listening to me? So I like to put this slide up here because it really, the first thing is on the far left is a Sinclair ZX Spectrum. It was the first computer I ever used in something like 1982. It was an amazing computer, and it was the last computer I actually truly understood everything about. Since then, since that time, I think we've got to a point that everything is a distributed system in some way, shape, or form, and is actually, you now have to deal in abstractions. At that point was really the last point, I think, where it was possible to actually treat the computer like a concrete thing. I have a picture of my lovely wife on there because I actually think it's really important to convey the fact that I do not have a doctorate. She does. I am a practitioner. I've been doing this for a very long time, but I do not have the academic chops that almost certainly most of you have. What I did is I married real smart, so I think that that's an important thing to put up there. And last, my 3 dogs. If it was up to me, I'd give you a talk about how to clicker train dogs properly, but that is not the appropriate subject matter of a KDD talk, so I'll leave it at that. So a quick little bit about my career. In 1996 was when I got involved in something that begins to resemble what I do now. It was my first account on a supercomputer. I found out that it was possible to have a computer with more than one processor, and my mind was blown at this idea. Since then, I got involved in soft computing and machine learning, just genetic algorithms. I hired my first machine learning engineer in 1999. Because I was really convinced that if you took user buying patterns and you took outcomes and you sort of tied them together with, at the time it was an R2 neural network, that you could do really good predictions. And it worked out well. We ended up being acquired by a publicly traded company. It didn't work out so well that I don't still have a job. So, it's up to you to decide how well it worked out. After that, I went into measurement and logistics and manufacturing, moved to the West Coast in 2012, became an advisor to Domino Data Lab in 2013 when it was just basically 2 guys and an idea, became the chief data scientist at Domino Data Lab in 2015, and then something happened, but we won't cover that. So the motivation here, so this is, again, the meat and potatoes of this talk. What are the high-level lessons that we've learned about the work that is data science? And the fact of the matter is, whether you want it or not, models are going to be running your business, are currently running your business, or are running your business into the ground. That is just an absolute fact. And one of the problems that we have now is that model development and the work of data scientists, there's a significant problem with actually quantifying ROI. It's actually become tough for data science organizations to actually point and say, this is the way that we added direct value, because it used to be that there was a wall between the modeling work and the engineering work, but as it's become more and more entrenched, it's actually really hard for organizations to point to what ROI they created. The quality of this model is fragile. All it takes is for a schema to mutate, for the value of a categorical to change fundamentally, and all of a sudden, not to mention, and I'm sure this will be covered in the second talk or not in our panel, the mismatch between your transaction processing system and your analytical processing system. There's no guarantee even that the way that you trained your model has any reflection to the data that'll actually show up in your model. Best practices are not codified, right? Like there may be a wiki that some intern did something in 2015, but none of that is true anymore. It's all lies. As a matter of fact, if you even look at it, you're just going to be misled. And the fact of the matter, as my previous employer found out, there's high turnover in this field. If you know what you're doing, even a little, you will get poached. Congratulations. Like literally, this is a fantastic time and place to be. So if you're actually somebody who cares about the longevity of these modeling projects, these data science projects and all of that, there's a significant amount of risk management that you have to do. And a lot of this ties to the idea that many data scientists think of their work as solo work. They think of themselves sort of in this hero model. The sociology of this fascinates me. I think a lot of it has to do with the fact that so many data scientists are previously academics, or they went through the academic Prussian schooling system that has this publish or perish mentality, and where they had to basically hoard everything. There's entire conferences and algorithms discussing who it is that should get placement where inside of an academic paper, who should be the lead author, who should be co-lead, and all of those things. These are things that are really deeply worn into the grooves of the practitioners, but actually have nothing but harm when they're actually brought into the real world. And the fact of the matter is that the best organizations work together as a team to advance collective knowledge, right? That I don't think that's a controversial statement. But this is easier said than done. I use this slide, but I'm not crazy about it. I used to be a beekeeper in a former life, and this slide makes it seem like all the bees are the same, and the implication here is that data scientists are just all this same copy of all these people that are sort of working toward this collective goal. If you've ever kept bees, you know that actually there's many types of bees in a hive, right? From drones to guards to queens to everything in between. And the key is that they all have these very specialized roles, and they have to work together. A top White House aide for our former vice president said that the vice president had been particularly intrigued by the idea that the crucial stumbling block to advancing cancer research may be poor collaboration among researchers. They jealously guarded their data so that advances and the same studies in the work is being replicated time and time again in multiple locations, wasting resources. This is an unfortunate side effect of the way that this, science is funded and the way that science happens in the real world, but this is wholly unacceptable for the way that data science is, a praxis in the commercial world. There's also a problem that we have as data scientists, is that we fetishize aha moments. We have this belief that the way that data science and indeed science move forward is through this revolutions, right? Like Thomas Kuhn's structure of scientific revolutions, there's this aha moment and something happens. But when you actually do an analysis of the way that science evolves across time, it has very little to do with these giant steps. It's actually compounding lots of little insights time after time after time. And this is not something that data science organizations sort of admit to themselves or bring into their organizational design. So they design organizations built around the hero model and this sort of punctuated equilibrium model of insights, where in reality they have to build organizations that allow for each other to stand on the shoulders of giants, right? I like this chart specifically because if you put a model into production today, that model is getting worse every single day. Behaviors are changing, covariates are changing. If you happen to be in a field that is adversarial, there's literally people almost certainly just as smart as you working very, very hard to figure out how to subvert your model. If you're designing an organization that has incredibly long feedback loops, incredibly long time slices, your model is going down 1% every day. And what's happening is that you're waiting for a jump that may or may never come. However, if you design your organization in such a fashion that what you're doing is you're encouraging agility, refinement, sharing of information, and collaboration, you're looking to build your model just 1% better every day, week, whatever unit of time it matters. But this isn't something that happens by itself. You have to explicitly build it into your organizational design. And honestly, many organizations are looking for silver bullets, right? I said we have a fetishization in our industry for this sort of hero model. This is only second to the fetishization that we have for silver bullets. We want to believe, maybe not those of us in this room who are practitioners, but I guarantee you the people directly above us want to believe that our job is just one step away from being automated, or that we're one step away from like not having to have the data engineering group, or maybe we'll just be able to get away with one person with like ML that magically MLs the ML. The fact of the matter is that there are no silver bullet tools, but here's the really insidious part. This Gartner hype cycle actually shows, something that everybody kind of agrees with this hype cycle at this point. But when you reach that peak of inflated expectations, that is when the silver bullet sales extravaganza comes into town. Because at this point, everybody knows that there are these things that can happen, right? And everybody knows that there's value, but the fact of the matter is that hey, building an organization is hard. Building a good organization that is sustainable is literally the grand challenge problem of scaling. And this is a fantastic time to go up to people who maybe missed quarterly numbers or are finding out that data scientists are hard to hire and they're finicky and they want access to data and whatnot. Gosh, wouldn't it be nice if there was a silver bullet that could just take care of our needs right away? And so you have to be wary of these snake oil salesmen. Because it's actually not a silver bullet that does anything, right? If you're trying to build a table, I don't care how good your planer is, sometimes you're gonna need a joiner. I don't care how good your joiner is, sometimes you're gonna need a ripsaw. The fact of the matter is that when you're trying to build something, what matters is having agility to quickly use many tools, to be able to reach into your tool belt, to try something out, to see if it works, to know that if you need a new tool, it's actually really easy to requisition a new tool and get it and make it available for you and be trained on how to use it so you don't lop off your fingers trying to build that table. It's important to have all this available to you, which goes a little bit at odds, right? Because leadership believes that they want to believe that the edge is in the technology, right? They want to believe when the CIOs get together, and if any of you are CIOs, my apologies for using you as an example, but when they get together at their fancy steak CIO luncheons or whatever it is that they do, they don't talk about it's like, hey, I've built this team and it's really good and these are reasonable folks. They want to talk about how great their algorithm is or how big their data, their data warehouse is. They believe that technology creates the edge. And it's actually really interesting because they become the gatekeepers to bringing in a new vendor or a new tool in the shop. You actually get in this situation where tools vendors are constantly fighting for attention to get every possible checkbox checked off. Does your tool use Spark? Yes. Does it use deep learning? Yes. Does it use literally whatever the new thing that just came out in the latest journal is? Absolutely. And what you end up with is this silver bullet hype cycle that ends up causing a lot of harm. But it's not tools, right? It's not going to matter how many amazing tools you have. The outcomes come from a culture of discipline. What do I mean by discipline? Well, in our field, discipline is stuff like pre-registering your experiment, actually saying what metric it is that you expect to get, actually managing the data pipeline in concert, with the experimental framework, actually having a reproducible framework around all of it. You need collaboration. Why? Because it's unlikely that you know everything about the space that you're working in. And all of these things that I just said about the pipeline, about making it all reproducible, it's of no use if it lives on your laptop and you walk away from the company. It's of no use if you bring in an intern and it takes them half the time of their internship just to get access to the data source. And like I said previously, you have to have this culture of constant improvement. But there's one other thing you have to be aware of when you're building these teams is you've got to be prepared for challenges. Literally, regardless of what you say, you can absolutely positively expect that the data are going to show that your conclusion is at odds with a closely held belief of somebody in the decision chain. They're going to fight you. Pride is going to get into the way. And unless you've built this bottom-up consensus, this agility, this access to tools, this access to everything, it's going to be nearly impossible for you to take your outputs and your benefits that you've generated in your data science process and operationalize them and actually make them impact your business. So again, so you got people, processes, and technologies. You've got to go beyond the hype of tech, right? AI, ML, whatever it is that it is. I actually, at this point, I no longer actually know what AI means. I thought I knew at one point. AI has now become a completely, I think we were discussing in like logistic regression is AI now. So welcome, we're all AI practitioners. And the fact is that like these like gross thing that is like, oh, you need discipline and rigor. Those are the real secret sauce, right? Like that's actually what's going to allow your organization to transform and your organization to take on its new way of being. So what is it, you know, what are the technical bits that you need? What are the components that you need to build into your data science process, your tooling in your organization? Well, you need to have a collaboration framework, and that collaboration framework, it can be Slack, it can be groups, it can be IRC, it can be GitHub, it can be whatever it is, but it has to be something that is accessible, that is apparent, that is transparent, that is grokkable, that is searchable, right? You need to be able to have a shared context. You know, there's the thing I was saying about the intern is true, even if you're not an intern, right? If it takes you weeks to come up to speed on a project because all of the context is locked inside of the individual contributors' minds or their laptops, then you are not able to scale that effort. You're not able to scale that organization. A lot of this comes around because of discussion, and you need to build in a discussion infrastructure. What I mean there is it can be comments, it can be peer review, it can literally also just be the practice that every Friday we get together and we have a bag lunch, and it is the role of one of us to present to the team, hey, what did I do this week? And to be clear, this discussion has to be biased towards truth, not towards flashiness. If you're doing data science right, then most of your experimental paths are going to be dead ends. If every path you're taking ends up being fecund, either you're in a space that literally no one has ever looked in before, and congratulations for having the lowest hanging fruit of all time, or as an organization, you're not admitting the things that you're doing wrong. And I think it's important in your discussion to explicitly incentivize people to talk about the processes that they took and the things that they've tried that do not work. And on top of that, you need to add search and discovery. How you do this is up to you. It can be Elasticsearch, it can be lots of different tools and technologies. But it's important that every experiment be searchable. It's important that it be cross-referenced to what metrics were necessary, what language was used, what databases did it leverage. You need to be able to sort of navigate through the experimental path and navigate through that in a search fashion, because you don't know what you don't know before you enter into a data science lifecycle. So you need to be able to sort of stab around in the dark and get some ideas. On top of that, you need to build in reproducibility and reusability. You should be using your code in such a way that you're building reusable packages. You know, if you're using R, if you're using Python, whatever it is that you're using, you have to be building reusable building blocks. If you're fortunate enough to be using some of the nicer ML libraries out there, you know, they already make it really easy for you to sort of save the models off, parameterize them, document them, and have them put aside. Same thing with your data. You need to have some way to actually know this data are related to this experiment, and you need to be able to do so in a reproducible fashion. Same thing with results. You need to be able to go from a result. This could be either a dashboard that is generated, a plot, a chart, a model, and you need to be able to trace back and understand, at the very least, who is the person of concern that actually generated this thing. You need to be able to have this ability to say, this model in production that has been scoring, I don't know, the goodness of a lead, you know, for the last 2 to 3 years. Who owns it? Who cares about this? Who's been carrying and feeding it? Who's been making sure it's retrained? Who's been making sure that our assumption in our model validation as to its accuracy 3 years ago when we deployed it is still even roughly sane? And you need to be able to manage environments. One of my favorite little stories is I was talking to a hedge fund who ended up using our product, and they had built in R a model that basically provided trading signals. Like they would feed it in a bunch of trading data, and then it would say we have to either get in or get out of this particular product. And the modeling team built it, and it worked fabulously, and in validation it was great. And you know, they took the code, zipped it up, it was in GitHub, and their actual team that makes the decisions downloaded the code and ran it on their laptop. And they were fortunate to discover that for literally the same exact point in time, it was giving completely different buy signals on the development laptops as it was on the production laptops. They ended up tracing this down, and this nearly cost them literal billions of dollars with a B, and it ended up coming down to the lubridate package. There had been an update that Hadley had figured out something about date parsing, and dates that were previously parsed as NA were being parsed as January 1st, 1970. And by not having that environment controlled, all of a sudden these models were giving completely and totally different signals. And this is just one package inside of the dependency chain. If you think back to all of your analyses and your models in production, what does the actual dependency chain that they rely on, the millions of little tiny finicky bits that have to be shaped just right for you to be able to do your work, what does that actually look like, and how do you manage that complexity? One of the cruelties of models is that if you feed them questions, they will give you answers. They will never tell you, hey, I'm unqualified to give you this answer, right? And so that's something that we have to guard against as professionals. And then finally, agility, right? You need to have experimental agility. You need to, like I said, have access to tools and packages, compute. If your data scientists are sitting around like waiting forever for their wheezy laptop to be done building a thing, this is not a good use of your data scientists. Not to mention the fact that there's bad use of their time, bad use of compute time, and the opportunity cost that you're missing in literally not being able to iterate more, literally not being able to try out more models, more audacious ideas, new feature engineering strategies. You're literally sitting there bottlenecked on silicon, and in 2017, that is pretty preposterous. So all of this is great, but the fact of the matter is, I don't know if you've met data scientists or quantitative researchers, but we're kind of an ornery bunch. So how do you incentivize this sort of best practice? Well, the idea is that I kind of like this picture, right, of this cupcake with the medicine on it, because you've got to make it delicious, right? You've got to make it something that people want to use, right? Data scientists have to use your infrastructure because it makes their job better. It makes it easier for them to test ideas faster, makes it easier for them to deploy and share work easily, makes it easier for them to get kudos. It makes it easier for them to be appreciated, for them to see who's using my tool, what is the impact that I'm really having. A lot of that is what really drives data scientists, is sort of that social proof that, hey, the thing that you did actually really generated value for me. And if you do this right, it's going to provide best practices for organizations, right? You're going to have powerful collaboration features. You're going to have version control and reproducibility. It's not, right, your files aren't going to be sitting on a laptop with like foo.back, foo.old, foo.use this one, and like somebody just has to remember that it's actually foo.old that is the real production model for some reason. So this is fine, right? Like this is fine to say, but it's important to say it has to be a buffet. You cannot from top down determine what your data scientists can use at the micro scale. You can decide what is at the buffet. You can decide, right, whether you want chana masala or you want barbecue in your buffet. That's fine, that's acceptable. But when it comes to your data scientists' work, they have to be able to sort of pick from the buffet and feed themselves and decide what it is that actually brings them value. And if you do this right, you realize that what you're actually building is a system of record, right? Every major business function has a system of record. Go up to your sales organization and go, hey, I want you to run sales. I want you to actually expand to me. I want you to do this work, but you don't get to use Salesforce. That's not going to go over, right? Go up to HR and say, hey, you're doing a great job. We want you to manage our workforce, but you don't get to use Workday. That's not going to function, et cetera, et cetera. And yet, as data scientists, we do our work on laptops in our own little Git repos without any real structure. And the fact of the matter is what you need to do is you need to build a system of record. And if you do so, like I said, in a bottom-up fashion that encourages collaboration, agility, and access to tools, you're going to get a lot of value. So let me show you some bits and pieces that matter. And I'm going to talk to you about really what are the 4 bits and pieces that I think are most important to doing this in a scalable fashion. You have to implement a project methodology. It can be very lightweight, it can be minimalist, but it has to exist. You have to decide that whenever it is that we're going to invest more than half a day of a data scientist's time, we're doing some work up front to ask questions like, why am I doing this? And writing it down inside of a file. What do I hope to accomplish? All of these things need to be sort of the macro container for this data science initiative. Inside of it, you need to be able to sort of address this project or initiative and understand what work was done, what work was referenced, what work was leveraged in order to push this forward. You need some tool to manage manage data science environments. Like I was talking about with that hedge fund before. What does that mean? That means that the particular configuration that you're using for building a model, the particular version of the library, the particular version of H2O, whatever it is that you need to be writing that down somewhere. It needs to be accessible. It needs to be easy to recreate. Why? Because if you work in a regulated industry, you're going to have to at some point recreate it. And if you don't, at some point you're going to want to hire someone. And if you've ever tried to bring up a laptop to run someone else's model, when you don't have written down at all what that model expected, what that pipeline expected, what was needed to actually bring up those transforms, it's a terrible, miserable job. And what will usually happen is people will give up and they will say, your previous data scientist was an idiot, don't worry, I know the latest, greatest way to do this, and they will re-implement it in their own way rather than have to rebuild their environment. And at that point, you're just spinning your wheels. You're not moving the state of the art forward. You need some experimental tracking framework. Every time you train a model, every time you validate a model, it literally needs to create some record somewhere. And it needs to say, this configuration plus this data plus this particular code generated this outcome. This can be done with many tools. It can be done with Domino, it can be done with Jenkins, it can be done with lots of different environments, but you have to have it. Otherwise, it's almost impossible to scale this experimental framework. And lastly, you need some tool to know what models you have in production. Right now, you have no idea how many companies we've worked with in the past that you go up to them and you're like, well, how many models do you have in production? And they go, we're not sure, we're doing a model inventory, but somewhere between 6 and about 400. And that's literally the genuine answer they give you. You need some way of knowing what models are in production. Like I said, who is the person in charge? When was the last time they were updated? When was the last time they were retrained? How were they retrained? What pipeline did it depend on retraining? Without these things, you're not going to be able to scale your quantitative research team, or you're not going to be able to move your state-of-the-art forward. And all of this needs to be tied together with search and reproducibility. If it isn't searchable, if it's not findable, it doesn't exist. If it isn't reproducible, if it isn't easy for you to just push a button and retry the experiment with a small tweak, nobody's going to do it. In my remaining 2 minutes, I'm actually going to show you Domino real quick. Let's see if this works. Voila. This is Domino. Domino is a web-based platform that we built, basically taking all of these things that we learn into place. Everything is searchable. So for example, if I'm a new data scientist and I'm asked to work on the housing problem, I can literally find all of the projects that have been used. Maybe I can find some data sets that have been used to leverage this particular idea. I can find who the people in charge are and actually know what to do with them. From here, I can deep dive, for example, into a project. And if I want to, again, a project is a unit of containment, I can say, well, what were people trying to do when they took on this project? And I can look at the documentation. This is just a basic wiki, right? But you need to have this documentation tied to the project and the initiative, which understands the metrics that you're trying to optimize for. You need to have an experimental framework that captures every experiment. So for example, here I tried to train a GLMNet model and a neural network model. I want to know, for example, when I look in details, I want to know exactly what exact revision of the data set was I using at that time. What version of XGBoost, what version of H2O was I pulling down at that particular moment? Further than that, though, I want to be able to, like I said, I want to be able to look at the environment and understand from this environment, when was it built, who built it, what packages are installed. I want to be able to do meta-analysis on these things. If I want to be able to compare, well, how does GLMNet compare when you compare it to a neural network? I should be able to actually look at a champion-challenger style model, see exactly, what was the training accuracy, what was the test accuracy, how did things change across time? If I overlay the confusion matrices for this, what does it actually look like to go from a neural network to a GLMNet? In this case, it doesn't matter because the iris data set is laughable, right? But you get the point. Let's see, projects, experiments, environments, and lastly, models. Once you've got all of this, you want to be able to publish a model into production. You want to be able to say, this is the model that I'm running. This is how you call this model. You want it to be self-documenting because data scientists will not document anything that isn't part of their literal performance review criteria. You want to be able to look at all of the versions of this model that have been deployed across time because you can be guaranteed that somebody will ask you, why did we deny this particular credit card request 7 months ago? You need to be able to tie it down. You need to be able to actually click through and see exactly what was the state of the experimental framework at the time? What was the state of the code? What was the state of the data? What was I looking at that point in time? And you need to be able to do this fluidly and easily. Now, to be clear, we built Domino Data Lab because we found these needs over and over and over again in organizations with 3 data scientists and organizations with 300 data scientists. There are other ways to address this. If you have an engineering organization and you want to build it yourself, you can. You can leverage open source tools. We leverage Docker. We leverage we leverage Scala. We leverage Unix, Linux. We leverage lots of open source tools. You can build something like this yourself if you have the time. But I will say that it is a non-trivial thing to build, and there's a lot of lessons that are baked into it. So with that, I think I've reached my time, and it's a privilege and an honor to open it up to questions if you have any. Thank you.